So what is isothermal change? Isothermal change is when the change of pressure and volume of a gas takes place without any change in temperature. Means we are changing the pressure and volume of a gas, but the temperature is kept constant. This type of change is known as isothermal. As the name suggests, isothermal. Iso means same, thermal means temperature. Means the change in pressure and volume of a gas is taking place at the same temperature. Now, isothermal changes must always be performed in a thin-walled, highly conducting vessel. Now, isothermal changes should always be performed in a thin wall. The wall of the container should be very thin and highly conducting. The vessel in which the isothermal change is to be performed, that vessel should be very thin walled and highly conducting. Why? Because mm, heat should be allowed, right? The exchange of heat should be allowed between the gas and the surroundings. There is an exchange of heat, right? But the temperature is not rising. In practice, there is no such conductor through which conduction of heat takes place as rapidly as required to maintain the temperature of the system constant. So, but a fairly close approximation of isothermal change may be obtained by causing the movement of a piston at a very slow rate, thus allowing sufficient time for transfer of heat between the gas and the surroundings by conduction, which means that the process of isothermal process should be very slowly done so that there is enough time to dissipate the heat or to conduct the heat so that no change in temperature takes place. And dissipate the heat where there is sufficient amount of time to dissipate or transfer the heat between the gas and the surrounding so that the temperature of the gas does not rise, right? So essentially isothermal process or isothermal change is a very slow process. We have already known from first law of thermodynamics q was equal to u2 minus u1. From the first law of thermodynamics we know that q is equal to u2 minus u1 plus W. Now, according in isothermal change, U2 is equal to U1, right? Initial temperature is same as final temperature. So, Q is equal to W. Q is equal to W. Equal to W. So, the amount of heat supplied will be used for doing external work. So, the amount of heat supplied will be used for doing external work. Okay. Now here in isothermal change, since the change in temperature is zero, since the change in temperature is zero, so what do we know? We know that Q is equal to mass into specific heat into change in temperature. Now, as this T is zero, so C will become infinity. C will become infinity because C is equal to Q by M into T, Q by M into T. So since T is zero, so C is infinity, which means the specific heat at isothermal molar specific heat in case of isothermal change is infinity. Specific heat in case of isothermal change is infinity. Molar specific heat in case of isothermal change is infinity. So work done in an isothermal process. The work done in an isothermal process, in order to find that, we will start with the equation of state for n moles of an ideal gas. This is the equation of state for the n moles of an ideal gas. PV equals to nRT. Now work done is equal to from the change in volume is from V1 to V2 at constant pressure. If the pressure is variable also, it doesn't matter. So initially the volume was V1, now the final volume is V2, PVV. Now what we have done? We have done just, we have multiplied this V and divided by V. So if we multiply it with V and divide it by V, we get P capital V dV by capital V. So P, capital V is nRT. So that nRT comes outside as all the three are constant, and we get dV by V. And we get dV by V. If you don't understand, let me write it down for you. Instead of P dV, we can write it as P V dV by capital V. We have multiplied and divided by V on, in the numerator and the denominator, and EV can be written as nRT dV by V. And now since R is constant, N is constant, capital T is constant, we can write instead of PdV, we can write nRT dV by V. And since nRT was constant, we have taken it outside the integration sign and we have got within integration dV by V. And we know what is the value of integration dV by V. It is logarithm of V1, V2 minus V1, logarithm to the base E, ln logarithm to the base E V2 by V1. And if the final pressure is P2 and initial pressure was P1, then since PV is constant according to Boyle's law, we can write nRT ln E1 by P2 because we all know E1 V1 was equal to E2 V2, right? So V2 by V1 can be written as P1 by P2.